All right, guys. So, of course, today is the quiz for the rest of Chapter 6, right? So if you have any questions related to that, feel free to ask. I got somebody else coming in. All right. Or if you have questions, so questions from 656667, right? That's what the quiz is going to be on. I've already got it put up on Canvas. I just haven't made it active yet. So as soon as the lecture's over, I'll make it active. I'm going to have to say all this again here in a minute. All right. Let me see. Is anyone else going to join us? Well, here, while we're waiting for people to join us, you guys have questions? Here we go. Here's some more people. Do you have questions? Do you have from homework, from anything? Do you want to do examples from somewhere? I'm a little bummed out. I put the video up that had exponent examples and a polynomial division example. Nobody watched it, so I guess you don't need too many of those. That's all right. It's okay. Thankfully, I don't monetize them and make all my living from YouTube videos. All right. Okay. So give me let me see. Who wants to do another division example? Say yes or no. Everybody vote. You guys know where the yes, no is?
Yes.
So if you hit the participants at the bottom of the screen, you should be able to see everybody's name. And then at the bottom of there, you should see the yes, no, go slower, go faster. This way I can see who's really here. So if you can't, there we go. I see some more. I see some more. I know you're there, Hayam. Have you want to vote? Let me see.
Yeah, I'm here.
Are you guys really out there? Everybody else? Whoever doesn't vote, I'm going to let you do an example for everybody. Or, you know, you might not even be here for real. So 5 people have voted, and I've got 2, 4, 6, 8, 10 people here. This is kind of weird. 6 people have voted. 1 person took their vote away. All right, this is freaking me out. I love you guys so much. I'm going to start calling you out individually. See, Kayla, you just got here. We're voting on if we want another long division example. So go ahead and vote over there, yes, no. If you click participants at the bottom of the screen, you'll see the yes and no and the go slower, go faster. So Kayla, please vote. Samir, or Mohammed, are you out there? There you are. Give a quick vote. Yes or no? I think that's almost everybody. I see you at least, so I know you're there. And Hayam, I don't know. You were there. Okay, enough of that. All right, so
Yes.
most you guys are really there. There she is. Okay, you're good. So let's do another example. Let me turn off the ocean. My little Finding Nemo background. Be gone. Okay, all right. So let's see. All right, now things are different here. Oh, somebody else is here. Bam. Oh, somebody else is here. All right. Now everybody's coming. Great. All right, here we go. Oh, boy.
I'm here.
All right. All right, let me get this as close as I can. There we go. Okay, so let's do this one. Let's see. Let's do one that's not too freaky. Okay. All right. I don't know why it seems so dark in here today. Does that look okay for everybody? Can you guys see that all right? Okay, thank you. There we go. All right, so by now we should all be very familiar with this first step. We look at the first parts. X times what is x squared? Who can tell me? X. I love it. Right? Got it. All right. So x times x is x squared. So then I take what I put up here. X times x is x squared, like I just said. X times 1 is 1x. And then, of course, what do I do now?
Subtract.
Subtract. So change the sign. Subtract. I like it. I like it. Every step we've taken so far has been the exact same step for long division of numbers. They are the exact same steps. These cancel. 2x minus x is x. Bring down the minus 5. X times what is x?
1.
So then 1 times x is x. 1 times 1 is 1. And then, of course, I change the signs. Plop. Negative 5 minus 1 is negative 6, and that's the remainder. Crazy sauce. All right. That is fundamentally the steps. I can put more stuff, I can put bigger powers, but the steps don't really change. They're the same steps. Let me see. Oh, here it is. All right. So let me give you guys another one to try. So we got that one. Can I erase that one? Daniel-san, show me. Erase the whiteboard. Okay. It's gone. It's too late. So here, you guys do this one. Let's see. You can do it, Jeff. Yeah. Who's coming in here, Curtis? Wait, Curtis, don't go away. Okay. All right, so go ahead and do this one. Go ahead. Do it. Yes, somebody's saying yes. Yes. Do it. While you do that, I will provide horrible background music for you. What am I drinking? God. All right, let me try something out. Let me see what you guys think about this. I'm just going to try this out. You guys all got that problem written down, right? Everybody's got that problem, hopefully, because otherwise, the hell are you doing? Okay, so I'm going to do something so exciting. You're not even going to know what to think. You're about to get a message. All right. I want you guys, I'm going to put you into groups. I'm going to put you into groups. I want you to talk with each other about the steps you've done. Okay, here we go. We're going to try this. You ready? You're going to actually have to talk to people. So hopefully everybody's really there. All right. Here we go. So you should get a message in a second to go to a room. So go to your room. Go to your room. Okay, good, good, good. I like it. Eileen, Lionel, are you out there? Eileen, Lionel, are you out there? Eileen and Lena. Okay, good. What is happening? Let me see if I can see everybody. Is everybody back? Did everybody make it? Looks like you did.
Yes.
What do you guys think about that feature? Is that tolerable? Does anyone have any opinions?
That's okay.
All right, I'll stop. All right. So maybe I'll make that something official. Because I mean, that's the one thing well, it's not the only thing. That is one of the many, many things that are missing now that we had to go online. Kayla and Savannah, did you end up together? Is that what happened?
Yes.
That's hilarious. You're in the same room, I love it.
We still talked about it though.
No, I'm with you. It was just a lot easier for you guys to do that. Yeah, because I did it like I made it choose people automatically. So it just randomly chose people. So that is kind of funny. I saw that you guys were in there together. And what I'm able to do is I came into a few of your rooms. I could actually go into your room. I don't know if I'm invisible when I do that, to be honest, because
I didn't see you.
Oh, well, I might not have come into you guys' room. I just went into a couple rooms and then I decided to shut it down because it looked like everybody was doing pretty well. What's happening? Oh yeah. Oh, you saw me. Thank you, Melissa. Okay. I didn't want to be invisible. Good. All right. I think I was muted and I didn't realize I was muted because I was like, hey, what's going on, guys? And then nobody said anything. I was like, all right, I'm going to leave. So anyway. All right. So let's all catch up here. Hopefully there was some headway made. So again, x times what is x squared? So that's obviously x. Let me do this. Wait a minute. What's happening? There. Okay. X times x is x squared. X times 4 is 4x. And then, of course, I change the signs. These cancel like they always should. 10x minus 4x is 6x. Bring down the minus 2. X times what is 6x?
6.
6. It's crazy. 6 times x is 6x. 6 times 4 is 24.
Yes.
And then I change the signs. These cancel like they're supposed to. Negative 26 over x plus 4. Just to really make sure you understand, if I did take this and I multiply by this, I will get this. In fact,
Okay, Professor. Well, now we have positive 24. We have to change it. No
Yeah,
change. We have
just
to
like normal long division of numbers, you have to subtract here. Subtraction means change the signs.
Okay. Okay.
like
I got it.
Good,
Because
good,
I got the same, but I confused if I have to change it or no. But now,
Yeah, definitely. I like it. So I'm going to erase this. Is everybody cool with that? I'm going to erase this piece. Now watch this. So what I want to do is I want to do this. If I take that times this, it better be this, or else this whole thing is crap, right? You with me? It's going to be a little bit weird. You never have to do this yourself, but I just want to show you this once because I've said this several times, but we've never actually done it. So I want to do this in a weird kind of way. X plus 4 times x plus 6. Let me put that right here. And then x plus 4 times this. So these, look over here, these cancel, right? X plus 4 times this, these cancel. And this one is just a FOIL problem, right? Even though I hate FOIL, but too bad. So there's the minus 26 here. And that's what I get from foiling there. And then sure enough, I get x squared plus, where'd it go? I did something very wrong. Oh, I see. I was thinking ahead. That's hilarious, Jeff. 6x, 4x makes 10x. Good job, buddy. 24 minus 26 is minus 2. Shit. So sure enough, when I multiply that by that, I do get x squared plus 10x minus 2. Sure enough, I do. I don't know if that did anything for anybody, but I had to show you once because I've said that before. And I hadn't actually shown you that yet. Okay, that's enough of that. That's enough of that. Okay, I'm going to take this all away. It's going away. Okay. So, yes. No? Okay. Let me think. So chapter 6, the other stuff in there was the negative exponent stuff. I think we've done a lot of those. You can tell me if you want some more of those. And then, of course, the scientific notation stuff, which we did the last couple days, I think it was. All right. And then we got a little baby step into chapter 7 last time. I'm going to, oh, here, somebody's here. I'm going to pull the book up real quick just so I can do some straight out of the book. So remember chapter, let me know if you have a question about anything as I keep going here. Chapter 7 is all about factoring stuff. So let me ask you guys to help me with the problem here in a minute, as soon as I get this sucker open. Oh, the hills are alive. Ah. All right, here we go. Perfect. So I want you guys to do, here's a trip down memory lane, right? Do me a favor. Can you factor this, factor 18 completely? Factor 18 completely. Completely factor 18. All right. Uh-oh. Yeah, you got it, Melissa. Let's see. So why, if somebody said, okay, I got it, it's 6 times 3. So 2 questions. Is that the way you did it? Was that the first step you did? Some of you guys probably didn't do that first step, right? And secondly, is that done? it's obviously not done because I said factor completely. And isn't 6 still factorable? So did some of you guys start like this? Did anybody start like this? 2 times 9. And then,
I
of
did.
course, 9 is 3 times 3. So no matter which way you go, let me let some people in. Did people get kicked out? Poor people. No matter which way you go, you get the same DNA. It doesn't matter how you cut the guy up. You're going to get the same DNA. That was gruesome. Oh, well, things happen. So, all right. So that's obviously too bad for you. That's not the kind of problems you're going to see because that's, give me a break. That's old shit. We're going to be factoring variable expressions. Man, people are just coming right now. What the hell? All right. So for example, we started a few yesterday, but let me focus on something a little more basic so we can get the idea of this. What you got, Jeff? You can do it, buddy. All right. So what I want to think about on this kind of problem is to factor this. This came from something times something else. So a monomial times a binomial, right? So this is the result of a distribution. So what number would somebody have distributed? And another way to think about it is, what number goes into 12 and 30? What's the biggest number that goes into 12 and 30? Five does not go into 12. 6. 6 goes in. 6. And do they have any letters in common? No. This guy's got an A, this guy's got a B. They got no letters in common. So what would have been right there to make 12A? 6 times what?
2.
2.
A.
A. And of course, what would have been over here? 6 times what makes 30B?
5. 5.
All right, good. So this is officially called, unofficially, this is called what I call undistribution. Because you're undistributing something. Curtis, why? What's no? What's the matter? You okay? Curtis is just like, no. Okay. You're thinking backwards. What was in front of something to make this? So you're thinking, what do they all have in common? Because when you distribute it, they both get a 6. That's why you got to think, what do they both have? That would have been what was sitting out front. So the technical term for this is greatest. What's the biggest thing? Common factor. What is the factor? The biggest factor that they have in common, GCF. So this is called GCF factoring. Okay, so let's try one. Let's try another one. Let me see. I'm going to take this away. So let's try this one. Sure. Why not? All right.
Is that a 30 at the end?
That is the 30 at the end, yes. So you notice they don't have any letters in common. So you really actually only have to worry about the numbers. I'm going to bring in a problem with letters in a minute. Looking at the numbers, now you got 3 numbers. What number goes in all 3 of these?
5.
5, totally. So look what I do. Whenever I figure out what the GCF is, I don't think I made a big deal of it on the other problem. This is going to become kind of huge. You want to put a 5 right there. See how it's back set? So now I can put what's left here, what's left here, what's left there. So I don't lose anybody. See how it's offset a little bit? It's not a big deal. It's just a little thing, but man, it throws people off. So if I take a 5 out of here, what's 15 divided by 5?
3.
3. And the X and the Y are still there. 25 divided by 5. And the A and the B are still there. 30 divided by 5. And of course, how do you check yourself? The same way you check when you break up numbers. You multiply it 5 times 3xy, 5 times 5ab, 5 times 6, bam. Hopeful Tai Chi. Okay. Maybe. That's like a little G.I. Joe. All right. Let's try one where we have to worry about the variables. Nah, screw it. I'm going to take this away. You guys all got that one? Okay. Here we go. Let's do one that focuses on the variables now. Yeah, this might be all right. Wait, add one thing. Add fourth power there. Just do it. Just do it. So everybody's got that written down? Okay.
Is it 2 squared or is it a squared in the first?
That is a good question. That is a little offset. Is that better? A squared, yeah. I would never do that really in this kind of problem. Put like a number with a power. It's just the number, you know. Anyway. All right. The numbers have nothing in common. Is that cool? 2 and 3. Ain't shit happening with those. Now watch. He's got 2 A's. He's got 3 A's. And this is what we talked about yesterday. How many A's do they have in common then?
1A.
No.
2A.
2 A's. Right? And in fact, the real shortcut for this is you can always take out the lowest power variable. What's the least power on the A that I see? A 2. How many B's can I take out then?
2.
2. Because they each have 2 B's. So I always call it, it's sort of like, this is maybe not the best analogy, and I don't give a shit. It's sort of like the what's the word? The fair tax man or something. He'll take everything you got, but not more than you got. I mean, sometimes they try to take more than you got. That's not good. So I can take out, so I'm going to offset it a little bit. I can take out 2 A's. So we put A squared right there. And I can take out 2 B's. Now watch how nice this is. There's still a 2 there. Didn't take any numbers out. I had 2 A's. I took 2 A's. I ain't got no A's left. I had 4 B's. I took 2 B's. I got 2 B's left.
2 B's.
3 still there. Didn't take any numbers away. Had 3 A's. I took 2. I had 2 B's. I took both of them. I'm done. Because when I distribute this, I'm giving this 2 A's and I'm giving this 2 more B's. So when I undistribute it, I'm taking that many away. It's that simple. It's not horrific. Okay. Any questions on that example? All right, let's try to up our game a little bit. Here we go. I'm gonna erase this. I'm gonna erase it. Okay. All right, nobody's screaming. What am I at? 4? Okay. All right, let's do a little bit of a mixed thing here. Let's not do A's. We just did A's. Let's do W's. Yeah. That's wild, Jeff. All right. You can do it, buddy. Can you do it? Sure. So what you do when you have a problem like this, and it says factor, right? So we're going to learn many different kinds of factoring. I've got a handout that I'll put up later. It's got all the forms of factoring and the shortcut way to tell when to do what. Oh yeah. So when you have a problem that's GCF, greatest common factoring, greatest common factor, you go numbers and then you go letters as they come. So what's common for the numbers? What's the biggest number I can take out?
Four.
Yes, 4. So I can take a 4 out. How many W's can I take out?
3.
3. How many X's can I take out?
1.
1. And again, the shortcut on the variables are the lowest power tells you that's the one you take out because that's what they both have in common. I could take 4 away from this dude, 4 W's, but this guy's only got 3. What the shit would he do? So I try to, that's why I call it the fair tax man. He doesn't take more than you got, right? So 4W cubed, and then I can take 1X out. So what's left here? 16 divided by 4 is 4. I had 3 W's. I took them away. I had 4 X's. I took 1, so I have 3 left. Minus 20 divided by 4 is 5. I had 4 W's. I took 3. I got 1 left. I had an X. They took it. My X. Actually, I'm happy my X is gone. That's fine. All right. So let me see. Any questions on that? How do you know you're done? 4 and 5 have nothing in common. This has nothing but X's and this has nothing but W's. So therefore, you didn't leave anything in. So look here, if you would have taken a 2 out, this would have been 8 and this would have been 10. They would have still had another 2. So that's how you tell if you're done. Is there anything still inside that I forgot? No, they don't still share anything.
Why you don't put the X with 5W?
Say again, one more time.
Why don't put the X with a 5W?
What did I take out?
Okay.
I took an X out, right?
Mm-hmm.
He had 1 X. I took it out, so he's got none left. Now listen, you guys. Go with me for a second. How do I check this? Well, what do I do if I see this problem? Don't I distribute? Right? Don't I give this to both of these? Yes. Isn't that what distribution is? So when I undistribute, I figure out what I can take away, and then I take that away from both of them. 20 divided by 4 leaves 5. I had 4 W's. I took 3. I got 1 left. I had an X. I took it. I got no X's left. That's why, right? And if you did have an X here, do you get this when you multiply? 4W cubed X times 5WX, you would have X squared, not just X. Oops.
Okay, yeah. I can.
Yeah, okay.
I got it.
I like it. I like it. I'm not coming down on you if you don't quite get this. I just want you to realize people make a bigger deal out of this than it really is. It's really not that huge of a deal. Not yet.
Is this in the next section we're doing?
Say again, sorry.
Is this in the next section that we are doing?
This is the current section we're doing, 7-1, yeah. Is everybody with me? We're in 7-1 for sure now. We got a little baby step into it yesterday, and now we're continuing with like a toddler step now. Okay, all right. Let's try another one. Let's make this one even more. Look at that. Need some more room. Yeah. What you got, Jeff? Let's see. You could do it, buddy. That's exciting. Let's see. Yeah. No. Hold on. Sorry. No. Okay, that'll do. Yay, I got it to fit in there too. Yay. All right. So again, this happens in all of mathematics, almost all of mathematics. If you can break the problem you're working on down into parts, it'll be that much easier. So the first part of a GCF problem is the numbers. Just look at the numbers. What's the biggest number I can take out of all three? Anybody? What's the biggest number that goes in to all
8.
three? Sorry?
8.
8. So I can definitely take an 8 out of all three of those. How many M's can I take out?
3.
3. How many X's can I take out?
1.
1. Yeah, that's the most they all have in common, right? So again, I could take 3 out of him, but he would freak. I could take 2, but then he would freak. That's why you look at the smallest power to tell how many to take out. Now what's left here? 80 divided by 8 is 10. I had 4 M's. I took 3. Got 1 left. I had 3 X's. I took 1. I got 2 left. Minus 40 divided by 8 is 5. I had 5 M's. I took 3. I got 2 left. I had 2 X's. I took 1. I got 1 left. Plus 8 divided by 8 is 1. I had 3 M's. I took them. I had 1 X. I took it. So what's here?
1.
1. I love it. Thank you. Yes. Don't just leave that blank. That doesn't make any sense, because if I distribute, do I get all 3 things back? No. So that 1 has to be there. What is something divided by itself? 1. So the first step in a GCF problem is, what can you take out? So you put it over here. And then the next step is, take it out. Write what's left when you take that out of each piece. And how do you check it? Distribute. Make sure you get the same answer. Okay, let me know if you have questions. Is everybody all right? Okay, all right. So you guys try this one. Let me put that one up here. I'm going to take this one away. It's leaving. Mohammed, you doing okay? Yes?
Yes.
Okay. All right, let me give you guys one that's not too crazy. Okay, so do that one. Oh boy. Okay. Sorry, I made the mistake of looking at my email. Oh, Jesus. All right. So compared to the one we just did, this one's not as evil. So what'd you guys, let's see, what'd you guys take out for the numbers?
3.
Yes. So 3 goes into both of those. How many A's can you take out?
3.
3. I like it, right? Because they each have at least 3. How many C's can you take out?
2.
2.
2. Kick ass. So then you put the first term, what's left here, 27 divided by 3.
9.
You had 3 A's, you took them. No A's. You had 4 C's, you took 2.
2.
2.
Minus 15 divided by 3.
5.
5. I had 4 A's, I took 3.
1. A.
I had 2 C's, I took them. Done. Yay. Nothing but C's, nothing but A's. 9 and 5 got nothing in common. I know I'm done. Next problem. I like it. All right. Cool. I like it. I like it a lot. All right. I want to take kind of a, all right, let's try this. You ready? We're going to try something. All right. So we got this? Okay. So watch, I'm going to start with, all right, this is going to seem way too easy. Just no trick, no trick. I'm going to build up to something in a minute. What is it, Jeff? Yeah, sure. 4A plus AM. Sure. Let's just do that. Start there. This doesn't change anything. Let me just do this. MA. Okay, so 4A plus MA. This is almost too easy. No trick at all. I never try to trick anybody. The more I say that, the more it sounds like I'm trying to trick you. Just do that. What comes out? What's the only thing that comes out? What do both terms have in common?
A.
A. And what's left? 4.
M.
M. All right, let me stop for a second. Is that cool? You guys trust me now again? There's nothing tricky there. They only both had an A, so of course the A came out. I love it. What if this would have been 4B plus MB? It's trying to be a B. Do you see what I'm saying? That would have been B times 4 plus M, right? That's not amazing, is it? Did I have to pick A's? I could have picked B's. I could have picked W's. Are you guys, why would the M come out? Where am I at? Yeah, the M wouldn't come out, Curtis, because they don't both have an M. So this is all about what do they have in common? Here they both had an A, so the A could come out. They both have a B, so the B can come out. There's a point to this. Let me get there. Okay, so what if I write this? Let's see if you guys get this. I'm going to write the exact same thing down again. You ready? I was trying to be an M there. I don't know what happened to me. So see how there's an A and an A, so I took an A. There was a B and a B, so I took a B. What do I have now?
For what? YH? So Y4?
Hold on.
Y plus.
Mute. So do you see how this is now 4 times Y plus 1 plus M times Y plus 1? Okay. Only unmute when you're ready to say something. So hold on. Let me try this again. So here they both had an A, so an A came out. Here they both have a B, so B can come out. Here they both have a Y plus 1. Let me say that again. This term and this term both have a Y plus 1. Do you guys know what A is? No. If I tell you A is 3, now you know what A is, right? Well, yes, Jeff, because you told me A is freaking 3. Okay, I'm with you. Right? What if I told you B is 7? Okay, now you know B is 7. Great. So that's one number, isn't it? A is one number. B is one number. What if I tell you Y is 6? What number is this?
7.
If y is 6, because again, everybody, what the hell's a variable? What's a variable? I've said it so many times. Why do variables act like numbers? Because variables are
Unknown.
numbers that I don't know yet. So variables are numbers. So do I know what a is? No. Could it be 3? Sure. Right? Could it be 28? Sure. Could it be 18 billion? Sure, man. Go crazy. Yes, there we go. Curtis is like, dude, just stop. It could be anything. Okay, I'm with you. So y can be anything, can't it? So what if y is 6? What is this?
7.
7. Thank you. Isn't y plus 1 a number? Yes. Y plus 1 is a number. If y is 6, y plus 1 is the number 7. If y is 28, y plus 1 is the number 29. You guys see that? If a is 3, a is 3. Ooh, right? So there would be a 3 here and here. But if y is 6, this is 7, and this is 7. Then wouldn't they both have a 7? So what do they both have? They both have, I've written so much shit on here. Let me rewrite this up here. Just show you what happens and see what you think. It's really the same exact thing. 4 times this number plus m times the same number. So what do these two have in common? They have y plus 1 in common. Oh shit, you can't see it. Oh man, I'm getting a ton of emails. Damn. So what does this term and that term have in common? Y plus 1. So what can I take out? Y plus 1. The same way I took an A out, the same way I took a B out. Because those are numbers, right? Isn't y plus 1 a number? Some unknown thing. So that same thing is in both. I can take it out. In fact, let me go one further. Let me see if you guys remember this whole thing. Do either one of these have a y in it? The correct answer is no. Neither one of those has a y in it, right? Neither one does, and you're all like, what the hell is that, Jeff? No, I see y plus 1. Neither one of them has a freaking y in it. They both have a y plus 1 in them. The more you get that, the more you get the general idea. So like, does 10 have a 2 in it? Does 10 have a 2 in it? Yes. Oh, I see, okay. Does 10 have a 2 in it? Yes, because 10 is 2 times 5. Are you with me? Yes, yes, yes. Does 10 have an 8 in it? No. That's insane, right? Does 10 have an 8 in it? No. But isn't 10 8 plus 2? So what? So when I say in it, I mean factor-wise. I mean multiplication-wise, right? So let's see. So watch this. If I take a y plus 1 out, what's left in the first term? 4. And if I take a y plus 1 out over here, what's left? M. So it looks exactly like the a times 4 plus m and the b times 4 plus m, except here I don't have an a, or a b. I have a y plus 1, y plus 1. So this term and that term have y plus 1 in common. And then what's left? 4 plus m. In fact, I tell people, cover that shit up and just write what's left. 4 plus m is left. That's some weird shit. Anyway, all right. Let's try one more of these kind. Let's see. So what about this here? So let me ask you this first question. How many terms do you see up there?
2.
Good. There are 2 terms. The first term has an a and a 4y minus 7. The second term has a 33 and a 4y minus 7. So what do they both have in common? Do they both have an a in common?
Or
4y minus 7.
They have a 4y minus 7 in common. I love it. Don't say y. Ain't nothing up there got a y. Don't say 4y. Ain't nothing up there got a 4y. Right? They have a 4y minus 7 in common. So what do I take out? 4y minus 7. And what's left?
A plus 33.
A, yep, plus 33. How do I check it? Now watch, how do I check it? What's 4y minus 7 times A? A times 4y minus 7. What's 4y minus 7 times 33? 33 times 4y minus 7. Check. Done. Crazy. Okay. Believe it or not, that's still GCF. We just have to start to realize that little things like this are one thing. They're like one little package. It's a factor. It is this package times this business. It is one thing. And that's what we're really not used to looking at it as. I understand that. All right, guys. I think that's a pretty good spot to stop. It's just about time anyway. Anybody have anything they want to hang out and ask about? As soon as I shut this down, I'm going to make the quiz active on Canvas. So, in fact, I'll do it right now while I'm thinking about it. All right, so you should be able to go in there and see quiz 7. It's now active. It's been activated. So go do that. Ma'am, what's up? You all right?
I'm fine. Thank you. Bye.
You're welcome. All right, guys. So I don't see any questions from anybody, so I'm going to shut down and go get some lunch. Bye.
Bye.
Bye-bye. Okay.